Hi everyone. So this is going to be our next chapter and it is going to be about set theory. For today, we will be working on the first topic, which is about the basic set concepts. So for this topic, we will have the three methods of representing sets, identifying and recognizing empty sets, the use of symbols. We also have to use the set notation for natural numbers. We identify the set's cardinal number. We recognize equivalent sets, equal sets, finite, and infinite sets. So before we start, what is a set? Okay, a set is a collection of objects whose contents can be clearly determined. Now, each of those objects are what we call as the elements. Okay, now the set must be well defined, meaning its contents can be clearly determined, and the order in which the elements are written in the set does not really matter. So, for example, if you have the set A, B, C, D, you can have it's just the same set as C, D, B, A. All right? So the order of the elements does not really matter. Now, we have ways of representing sets. Now, one thing that you have to remember is that capital letters are used to name the sets. Okay? So the first way of representing sets is by using word description. So this is going to be like a one-sentence way of describing the elements or the members of the set. So for example, set W is the set of the days of the week. That's it, okay? That is the word description. So the name of the set is W, and then the description, what are the characteristics of the elements of the set? They have to be the days of the week. The next way of representing sets is what we call as the roster method. So roster, meaning you are going to list down the elements of the set. So given this example here, set W, okay, so we write using the capital letter W. It's always with the equal sign. Now, when we talk about set, we always enclose it with braces, okay? So what are the days of the week? So again, the order of the elements here does not matter, okay? So even if I have here a Saturday, Friday, Sunday, Tuesday, Wednesday, Monday, and Thursday, that is totally fine, okay? As long as you have all 7 of them in there, okay? Now, some important things when you are writing your sets, okay? We use commas to separate each element of the set. So as you can see, I have these commas here separating one element from a second element and so on and so forth. And as I have mentioned earlier, the use of braces signifies that these elements form the set. So do not forget to have your braces. You cannot be listing down the elements, just listing them down with commas. No, they will not be considered a set, only if you have them inside braces. All right, so let's have some examples here. So we need to write a word description for this set. You have set P, and it contains the elements Washington, Adams, Jefferson, Madison, Monroe. Okay. Now, if you will notice, all these names seem familiar because these are names of U.S. presidents. Now, we cannot say that P is the set of U.S. presidents because how many U.S. presidents do we have? There should be 46, I believe, okay? But you are only listing 5, so you have to be specific. When you are writing the word description of a set, it has to be as specific as you can. So you can say here that P is the set of the first 5, okay? Washington, Adams, Jefferson, Madison, and Monroe are the first 5. The first 5 presidents of the U.S. Okay? Presidents of the U.S. So again, it is important that you have to be as specific as you can because you only have this number of elements in this set. Let's have an example for using the roster method. So we have set C is a set of U.S. coins with a value of less than $1. So we're going to write this down in roster method. So the name of the set, as you can see, set C. So we start with a capital C, the equal sign, of course, and then we start with a brace. And now we list down all the coins that are less than $1. So we have the penny, we have the nickel, dime, quarter, okay? And of course, we also have the half dollar. Half dollar. All right, so enclose that with another brace. So it doesn't matter even if you started with a half dollar here, as long as you have all of these coins listed down in your roster method. The third way of representing sets is what we call as the set builder notation. So of all the three, this one is the fanciest of them. All right. So your set builder notation would look like this. You have the name of the set, equal sign. Now you can see here that there is a variable x. So this is read as all elements x. Okay, so we do not know which elements they are. That's why they are represented by the variable, such that, okay, this vertical line separates the elements from the condition. So this part is the conditions or the descriptions of how an element will belong to the set. Okay, now not at all times they will be words like this. Sometimes the conditions could be written in algebraic expressions like inequalities and things like that. So pretty much this is how it would look like. So we got to make sure that you know how to read this and how you can change them, let's say, into roster method. So like for example, this one, we have the set A. Set A is the set of all elements x such that x is a month that begins with the letter M. So this is our condition, a month that starts or begins with the letter M. Now we want it in roster method, so we need to list them down. So we have set A is equal to, what are the months that start with the letter M? That would be only two of them. It's going to be March and May. And so we enclose it with the braces. Okay? So as long as you know how to read this, you should be good. Most of the time, it's always the roster method that will be used when representing sets. Okay. Now, when there are no elements inside your set, that is what we call as the empty set. Okay. I mean, that's a simple definition. Empty. Nothing is in there. Which is also called as the null set. Now, there are two ways on how you can write your empty set. You can use just a pair of braces, nothing in between, or you can use this symbol. So it's like a circle and then you are trying to cancel it, something like that, okay? So what are examples of empty sets? So set of all numbers less than 4 and greater than 10. There's no such thing, okay? Everything that is less than 4 cannot be greater than 10. So this set is going to be empty. And then, of course, we have a set builder notation here. We have x, set of all elements x such that x is a fawn that speaks. So no fawn can speak. Okay, so let's have some examples and try to see if we are able to recognize our empty sets. Okay, so is this an empty set? Now, if you can see, you have your braces and there is something inside those braces. So this is no, not an empty set because you have one element in here. Okay. How about this one? Is this an empty set? Now remember, when we talk about set, first thing that you have to look for are the braces, the pair of braces. And we do not see any braces here. So definitely this is not a set. Why? We don't have braces. This is just a number 0. Okay. Next, set x, set of all elements x such that x is a number less than 4 or greater than 10. Now, if you will notice, it used the word or this time compared to and. Earlier, in the example that uses the word and, it has to satisfy less than 4, also greater than 10. They need to be both satisfied. Now, when you have the or, it's like you can satisfy this side, the less than 4, or it can also be true for those who are greater than 10. Now, we know that this part will not be empty. This is not going to be empty. Okay? If you list down these numbers, what are the numbers that are less than 4? You have 1, 2, 3, and then greater than 10, you have 11, 12, and so on and so forth. Okay, so this is not going to be an empty set. Next, set of all elements x in such a way that x is a square, okay, a square with 3 sides. Okay, definitely this is an empty set because all squares cannot have 3 sides. If it has 3 sides, it cannot be called a square. It's going to be automatically a triangle. Okay?